Okay, in this video, we are talking about the concept of limit. Look at the function. You can see that when we substitute x equals 1, the denominator equals 0. So that is undefined for f1. Now, we want to see that when x is very close to 1, and we want to investigate what is the value of fx will tend to. And now you will see that there is a table below. When x equals 0.9, the fx will equal 1.9. So you can fill in the table based on the different value of x. And you will see the pattern. When x is equal to 1, we don't know the answer. But we can see that the function is tends to 2. So we can see that when x is very close to 1, then fx will very close to 2. So that's we would say the limit of x squared minus 1 over x minus 1 as x approach 1 is 2. And the symbol will write in this way. Limit x tends to 1, x squared minus 1 over x minus 1 equal 2. And remember, limit x tends to 1 fx equals 2, it does not imply f1 equal to 2 because fx is undefined when x equals to 1. So you can just look at the graph here. Y equals x plus 1 is undefined at x equals to 1. So look at the notes here. Given a function fx and a real number a, if fx gets closer and closer to a number k as x gets closer to a, what does that mean? That means when x tends to a, then fx will tend to k in different direction of x. That means from left hand side x less than a and right hand side x greater than a. Both directions when x tends to a, fx will tend to k. Then we can say that the limit of fx as x approach a exists. Now remember, even though the limit exists, that does not imply fa must exist. Fa can be not exist, but the limit still exists. Okay, look at this example. You can see that there's a negative sign on the top right hand corner. That means as it tends to x to 1 from the left hand side. And you can see the positive sign on the top right hand corner. That means from right hand side. As you can see, from left hand side the limit tends to 1, and from right hand side the red arrow, that means tends to 2. Since these two limits are not the same, therefore the limit does not exist. When do we say the limit exists? That means the left hand side limit equals to the right hand side limit. Technically, in mathematical terms, we say the left hand limit equals to the right hand limit. Okay? With the negative sign, that means the left hand limit. With the positive side, that means right hand limit. Look at this graph. Left hand limit, that means we tend to the function when x less than c1, you can see that's 8. When right hand limit is also equal to 8. But f7 does not exist. There's a hollow circle here. That's undefined. So, is limit exists? Yes. Even though f7 does not exist because left hand limit equals to right hand limit, therefore we will say the limit exists. When x tends to 7, fx will tend to 8. Look at the second example. The left hand limit tends to 2, it equals to 8, the blue one. Look at the red one. When x tends to 2, with the right hand side, this tends to 3. You can see there's a solid number. f2 is equal to 3. So you can see that even though f2 exists, but the left hand limit does not equal to the right hand limit, so the limit does not exist. I repeat, the left hand limit means the blue one, the right hand limit means the red one. So you can look at all these. Part A, this is equal to 0. You can look at the blue arrow here, and part B, you can look at the red arrow here, that's 2. So you can see that the limit does not exist because left hand limit does not equal to right hand limit. Part D, same. You can see there's a negative 2. And part E, look at the graph, is tend to 0. So left hand limit does not equal to right hand limit. these two limit, okay, this limit does not exist. And part G, you can see that the left hand limit is 4 and the right hand limit is also 4. So the limit x tends to 4 is exists. And the next part we will need to talk about is the continuity of a function. That means we want to investigate whether the function are broken or not. And we have the test about the continuity of a function. It has 3 conditions. The first one, fa is exists. And second condition, that is limit of x tends to a, fx exists as x equal to a. And the third condition is limit of x tends to a, fx equals to fa. We need to satisfy all these 3 conditions, then we will say the function fx is continuous as x equal to a. Simply say fa exists and the limit x tends to a of fx equals to fa. Look at the first example. We can check the condition one by one. First of all, we check whether f3 exists. When x equal to 3, f3 will equal to 3 plus 9, that's 12. Alright, condition 1 satisfied. Second condition, when we check the left hand limit, that is 12, and the right hand limit is also 12. That means the limit is also exists. So you can see that when the limit x tends to 3 of fx equals to f3, you can make the conclusion that fx is continuous at x equal to 3. Simply say it's not broken at x equal to 3 or no hole at x equal to 3. Second example, we need to check the first condition whether f3 exists. You can see that f3 is undefined because the denominator is 0. So simply say f8 is not continuous at x equal to 3. That's finished. So we check this case one by one. fa, yes, exists, and the limit of fx and x tends to a is also exists, but it is not continuous. There's a hole there, okay? The limit, you can see there's a blue arrow, and fa there's a green arrow, so they are not equal. Second example, fa obviously does not exist, there's a hole here, and you can see that the limit is exists. So final solution, that is, this is not continuous at x equal to a. You can see that fa exists, there's a solid hole here, okay? And the left hand limit, right hand limit does not equal, so limit does not exist, so it is not continuous. Final, fa does not exist, the limit does not exist, and therefore they are not continuous at x equal to a.